So carrying on from the photosynthesis videos, factors affecting the rate of photosynthesis. So one is light intensity. And the second is CO2, it's the concentration of CO2. And the third one is the temperature. Okay. So bright light equals faster photosynthesis. Okay, and low light, so bright light you get faster photosynthesis on bright sunny days, and low light levels on overcast cloudy days when it's raining, lots of dark clouds overhead, equals slow photosynthesis. So the famous, there's a famous experiment I'll go over quickly, which okay, I will mention this briefly. There's a famous experiment using a plant called Elodea, which lives underwater. It's the Elodea So, you cut a piece of the plant and you count the number of bubbles, number of oxygen bubbles, released per minute, by the cut end of the Elodea. Okay? So, hello. This is an attempt to show how the water weed Elodea lets up bubbles and photosynthesizes. This isn't actually Elodea, but it's some bits of plant. What I'm trying to show you is if you have a light source that gets closer and closer and closer, okay, you should find that this photosynthesis rate of the plant gets faster and faster. You can't actually see oxygen bubbles coming off this because it's too slow. There are some bubbles which are visible on the surface of the leaf, but it's far too slow to see it. And, it's probably not. Also, Elodea actually lives in water, whereas this is a plant from a bush outside my house, and it's probably not the best one for doing it. But a quick reminder. So light comes in the plant sucks up water. The light splits water into oxygen, which is released into the air, and then hydrogen and energy, which are taken off for carbon fixation. Okay. So yeah, this is our, yeah, if you look let's try. So you can see more closely there. Okay, you can see bubbles there on the surface of the leaf. I think those actually might have been trapped air bubbles when I put the leaf into the water, but I'm just trying to demonstrate to you sort of roughly how this thing works. As the light source moves closer and closer to the leaves, ideally, if you can imagine, the bubbles should be released from the leaves more and more quickly. Okay, so this is the basis of how the Elodea water bubble experiment works. Okay. So a quick table which I'll draw out. So when the light source is 100 centimeters from the plant, 4 units of light are released. You get 4 oxygen bubbles per minute. So when I draw this table out, when the light source is 100 centimeters from the plant, 4 units of light are recorded. You can work out from a formula, and you get 4 oxygen bubbles per minute. When the light source is 60 centimeters away from the plant, there's 11 units of light, and you get 10 oxygen bubbles per minute. When it's 40 centimeters from the plant, 25 units of light are recorded, and you get 24 bubbles per minute. When it's 30 centimeters from the plant, you get 45 units of light and 24 bubbles per minute. At 25 centimeters from the plant, you get 64 units of light and 25 oxygen bubbles per minute. When it's moved to just 20 centimeters from the plant, when it's 100 units of light, you get 25 oxygen bubbles per minute. So the maximum is 25. So as the light source moves closer to the plant, the amount of light, number of units, gets bigger and bigger. The number of oxygen bubbles gets larger. The number of oxygen bubbles per minute gets bigger, but it reaches the limit at 25. Okay? This is our famous experiment. You put the you measure the oxygen bubbles coming out of the plant underwater. So as light intensity is increasing, as you move the light nearer to the plant, light intensity gets brighter and brighter. So the photosynthetic rate gets faster, and you get more and more oxygen being released. Okay. So it's reached the limit at 64 units of light and a maximum of 25 bubbles per minute.